Today, instead of our shoutouts, we have the distance learning pyramid. At the bottom of the pyramid, those early morning office hours, because I spend them all alone. No one shows up. Next on the pyramid, we have the warm-ups. They're helpful, but I'm not sure everybody's printing them out and practicing and doing the work and checking their answers. Next on the pyramid, we have Khan Academy. You guys were going strong at the beginning. That first week, numbers were in the hundreds. Things have dropped off. Next on the pyramid, we have the note sheets. Helpful for those of you that follow along with the notes. Not sure everyone's printing them out, but they're a good resource. The next level of the pyramid, we have our Google Forms. There's nothing more fun than a Google form. We love them. Next on the pyramid, we have that weekly raffle. If you haven't yet joined, make sure you join on Friday because they're a blast. Next on the pyramid, we have that Blue Team math site. It helps to keep us organized. You can go back, see anything that you've missed, and click on it. Next on the pyramid, we have Zoom because it's the closest thing we have to being together. Then on the pyramid, we have Flipgrid. Have I mentioned yet today how much I love Flipgrid? You should really check it out. And at the top of the pyramid this week, we have all of you because you are what makes the difference. And I miss each and every one of you. And so today we are going to learn how to factor completely. When we're factoring polynomials, you will always start with your GCF. So the GCF is the most important thing in terms of factoring. When we talk about factoring completely, sometimes you have to factor a GCF and then continue to factor even more. So you'll see with the examples, but we're always going to start with the GCF. Then once we take out a GCF, if there is one, we're going to look for special products. So we're going to look for a difference of two squares. So we're going to look to see if we have something like x squared minus 9. If we have a difference of two squares, that would factor into two binomials, x minus 3, x plus 3. Two conjugates, there's a minus and a plus. Then if we have four terms left instead of just two, we're going to do a split method. If we have a trinomial, we're going to unfoil with our little number puzzle or the lazy AC method. So this is best done through doing some examples together. So let's try the first one. Alright, so I need to factor this polynomial. It has three terms, it has a degree of 5, it has a leading coefficient of 4. It is currently in standard form. You always want things to be in standard form before you start factoring. Now I'm going to look for a GCF. 4 is the largest number that will go into all three evenly, so 4 is the coefficient. I have 5 A's, 4 A's, and 3 A's, so the most A's they have in common are 3. Then I'm going to set up my parentheses. 4A cubed would need to be multiplied by A squared to get to 4A to the 5th. 4A cubed would need to be multiplied by an A to get to 4A to the 4th. And 4A cubed would need to be multiplied by negative 30 to get to negative 120A cubed. So now in my parentheses, I have a trinomial. Before I say I'm done factoring, I need to first see if I can factor this trinomial anymore. So I would be looking for two numbers that multiply to give you negative 30 and add to give you 1. And those two numbers would be 6 and negative 5. 6 times negative 5 is negative 30, and 6 plus negative 5 is positive 1. So I can break this trinomial into a plus 6, a minus 5. But I also have my GCF, so I'm going to add that as well. So the final factored form for this trinomial is this. If you multiply these two together and then multiply by this, you would be back at this. For our second example, I have a trinomial. It's in standard form because it goes squared, c to the first power, c to the 0 power. And now I'm going to look for a GCF. So I can take out a 7 from all three of those terms. And then in parentheses, I would have 2c squared minus 5c plus 3. Now I can't say I'm done until I check. And I'm going to use the lazy AC method for this because this is not 1. I'm going to multiply these two together. I'm looking for two numbers that multiply to give me 6 and add to give me -5. And those two numbers would be -3 and -2. So now I'm going to write my two sets of parentheses with 2c as the beginning term for each, and then a -3 and a -2. This cannot be simplified, but this can be. So this can be scaled down to c minus 1. So my final factored form would be the GCF and both of my parentheses. So this would be what we would be looking for if we say to factor this trinomial. For my next one, I'm just going to bring the screen up a bit. Thank you, Maddie. I'm looking for a GCF, and there is no number that will go into all of these numbers evenly, so there's no number, and they don't all have C's, so there is no GCF. It is in standard form because it goes highest power down to lowest, and there's 4 terms. If there's an even number of terms, you're going to split down the middle, and you're going to look for a GCF on this side. So on this side, the largest number that goes into 42 and 24 would be 6. The most amount of C's that they have in common are 2, so c squared. My parentheses would then be 7c minus 4. If I multiply this by this, I would get to here. So now my parentheses over here also have to be 7c minus 4. So now I'm looking, what would I have to multiply this by to get to here? And I would have to multiply by -1. So in factored form, my two parentheses would be the GCS, which are 6c squared minus 1, and then 7c minus 4. Now I always want to look, if I have two terms, I want to make sure I don't have a difference of 2 squares. And this is square, but 6 is not a square number, so I don't have a difference of 2 squares. So this is my final factored form for this one. And then for the last one that we're going to do out in this video, I'm going to look first, I only have a binomial, I'm going to look for a GCF. They do have the number 2 in common. And then in parentheses, I would have 16d squared minus 1. Now, in my parentheses, I have 2 terms, so I want to know if I have a difference of 2 squares, and I do, because 16d squared is a square term. And I'm going to unsquare it to get 4d. 1 is a square term, so I'm going to have the square root of 1, which is 1. And then I'm going to have a plus and a minus. A difference of 2 squares becomes 2 parentheses, one with the minus and one with the plus. That's in math, we call those conjugates. And I'm going to have 2 as my outside because that was the GCF I took out at the very beginning. If I multiply all of this together, I will get back to this. So this is factored form for this binomial. The other examples I'm going to do out on Flipgrid so that you can try them and watch the quick video and see if you got the solution correct. So go to Flipgrid today